going to talk about 7, we're going to talk about base E and natural logarithms. The first thing you need to know is that this irrational number E, okay, this is actually a constant, and it's approximately 2.701828. So if you don't understand what that means, just think of pi. All right, the number pi is an irrational number, okay, and it's a constant. So the E, base E, actually came from a formula that looks like this. As n gets bigger, that quantity approaches this right here, okay? Now the other thing you need to know is that when I talk about the natural log, which will be written like this, right, I'm actually talking about the log base E of x, okay? So this is the log base E of x, and so that's the same thing as the natural log. Okay, there are two inverse properties of this that are very important that I will use, and actually I use quite a bit, especially in calculus. What you need to know is that E and the natural log, they're inverses of one another. So if you just look at this side right here, if I have E to the natural log, they're inverses of one another, so therefore all I end up with is x. Similarly on this side, natural log of E to the x, this is actually, I think, a little bit easier to see. Remember, if it's a power, I can move it to the front, right? And if I move to the front, natural log of E is 1, so I end up just with x. Again, they're inverses of one another, so the natural log and the E are inverses of one another, and we're going to use those to essentially solve for things that we haven't been able to solve for in the past, okay? Now, at first, we're going to start off by writing an equivalent exponential or logarithm equation. In this case, since this is already an exponential equation, we're going to try to write this, I'd say, logarithmic equation. Now, in general, there's many ways to teach this, or as some people like to say, and which is not wrong, they would have log base E of x is equal to y, and if they want to write this as an exponential, well, what they do is they move this over here, move that over here, and then essentially they move this little b over here, so, to the y. So we have b to the y is equal to x, okay? Now, that tends to be kind of confusing for me. So what I like to do is, on this one, I like to think about it like if I want to write this as a natural log, and I am going to write this as a natural log because this is e, I like to think about it in this manner. Okay, if I take the natural log of both sides, okay, I would have that. Now the natural log of e, they're inverses. So remember that 15 can be moved to the front, so this is actually the same thing as 15 is equal to the natural log of x. Now notice that this is the same pattern that I follow here, okay? The other thing to note is that, for example, let's do one more. Okay, so on this one right here, if I have an e, I'm going to take the natural log of each side. So I would have the natural log of e to the 3x is equal to the natural log of 45. Now, if you remember from previous lessons, 3x can come to the front. Okay, and the natural log of e is 1. So what I have here is 3x is equal to the natural log of 45. So that's basically how you do it. Okay, let's see if there's anything tougher than that. Well, 3 is not any tougher, but you're going to go backwards now. So if I have the natural log, they want me to write this as an exponential function. Now to do that, I'm going to use base e, what we also call Euler's number, and I'm going to do this to each side. Now, e to the natural log of 20, they're inverses, so I end up just with 20 is equal to e to the x. Okay, so that's how that works. Let's do one more, number 4, but it's the same idea. I'm going to raise both sides to the e, if you will. Okay, so this is their inverses right here, so I end up just with x is equal to e to the 8th. So this one's not too bad, actually. Okay. And then now remember, e to the 8th, don't get that confused. E to the 8th would be that number, that 2.71 to the 8th power, whatever that may be. Okay. So let's go ahead and just get away from this, and we're going to just go to the bottom here. And in this one, they're asking us to evaluate each logarithm, all right, to the nearest 10,000. Now, on this, I don't really see a purpose of teaching you any other way other than the calculator. Now, if you grab your calculator, you do have this button that is the natural log, and you can actually see in blue this e to the x, all right? So anyways, but for now all we need is the natural log, all right? So we're going to press that button. Okay, and once we press that button, we're just going to put all of this. So this should be completely done on the calculator. So that's the answer, 9.4, since we're rounding to the nearest 10,000. Okay, never mind. This is 9.10, 100,000, 10,000. Okay. So that's what we have for that. Okay, and that's essentially what you do the whole time. You use the calculator for all of these that look like from 9 through 16. So I'm not necessarily going to go over this. All right, where stuff gets a little bit more interesting, I would say, is it's like on the back. Okay, now in this one we're going to try to solve. Okay, we're trying to solve each one of these equations for x. Now to do that, what we're going to do here is actually very simple, right? So let's look at example 1. All right, on example 1, all right, to try to get to this, all right, we're going to use the natural log of each side. So again, we're going to try to use the natural log of each side, because only the natural log allows me to bring this 4x to the front. Okay, so now that's gone. And the natural log of e is just 1. So I end up just with 4x is equal to the natural log of 120. So one more time, in case you're not understanding, right? If I have the natural log, and I'm going to put it in the calculator here so you can see it. Natural log, and notice that the e number is right here if you just want to use that. So the natural log of e, since they're inverses of one another, they're essentially canceling one another. Or in this case, that's why I say that it's 1, because it is. Okay? You couldn't actually see that. That's weird. Anyways, it is 1. So now, to solve for x, now all I have to do is divide this by 4. Now you just have to be really careful. Plug it in exactly like you see it. All right. So we have, in this case, the natural log of 120, and then we're going to divide that by 4, and that's the answer, right? So we're rounding to the 4th decimal, essentially. Yeah, we're going to round to the 4th decimal point. So this would be x is equal to approximately 1.1969. Okay. So that's it for that problem. Now let's go on to number 2. Number 2 is quite a bit easier. Okay, now again, I have an e to the x. To get to that power right there, I'm going to use the natural log. Okay, so we have the natural log of e to the x is less than or equal to 25. Now remember that the x over here can be moved in front of the natural log. So this would be x. Natural log of e is 1, so oh, and excuse me, I did not write the natural log of 25. Whatever I do to the left side, I have to do to the right side. Okay. So we have less than or equal to the natural log of 25, whatever that is. Alright, so we have x is less than or equal to, and I'm just going to plug in natural log of 25 and see what happens. So we got 3.2189. 3.2189. Okay? Now let's go ahead and move on to something more difficult, like number 3. And number 3, but it follows the same pattern. Alright? And on this one, by the same pattern, I mean, here's the thing you have to do first. You have to isolate the exponential term. In this case, that's this term. Right? So I'm going to start off by subtracting 4. So again, start off by subtracting 4. So I have e x minus 2 is equal to 17, and I'm writing that 17 way over here for a purpose, because right after that, since the variable that I'm looking for is in the power, I'm going to take the natural log of each side. Okay, now when I take the natural log of these side, remember that this right here can come in front of the natural log. So again, I can write it like this. Okay, and that will go away. Natural log of e is 1, or it cancels out, so I end up just at that. It's equal to the natural log of 17 on the right side. And then now I'm just going to add the 2. So I'm going to add 2 to each side. This is a point where I wish I had more room than that, but this is just the way it is. So I have natural log of 17 plus 2. Okay, in my case that's 4.833. Let's see, 4 decimal points? Yeah. Excuse me, 332. Okay, so that's it for that problem. Okay, so all of these that have the natural log, all of these that have e, that's how you do them, right? Now let's go to a problem like number 4. Now this is a little bit backwards. Notice that the variable is inside this natural log. So to uncouple that, all right, to essentially set it loose, to get to the 6x, I have to use base e on each side. All right, so when I use base e on each side, that cancels the natural log. I end up with 6x on this side, and on this side I'm going to end up with e to the 4th. Okay? Now that I have that, again I'm solving for x, so I'm just going to divide each side by 6. And on this one you definitely need your calculator. This would be x is greater than or equal to, well, I guess we'll find out. And again, if you want to get to that, I mean, there's 2 ways. You can press second and this one right here, which is the division sign. It's kind of hard to see on the camera, but there's a division sign. Or you can use second and where the natural log button is. So anyways, this would be e to the 4th divided by 6. Okay, so 9.9. We have 9.0. Well, that's going to be 1. Excuse me, that's going to be 9.100. 0. Anyway, that's just the way that happened. Okay, so now, or let me see. No, I'm sorry, that's not right. I just didn't write that correctly, so let me do that again. Okay, this should be 9.0997. Okay, that's better now. So that's essentially how we're going to do it right now. If you do have a natural log, like number 5, I'm going to do the same thing. I'm going to add the 5 first. So again, isolate the natural log. So it's very similar to a radical. Isolate the natural log first. So we're going to do that by adding 5 to each side. So we have the natural log of x plus 3 is equal to 3. And then now that the natural log is isolated, I can go ahead and use base e on both sides. Now the left side, that's going to cancel, and e and the natural log are going to cancel out. I end up with x plus 3. And this is going to be e to the 3rd. And then now I'm just going to subtract 3 from each side. Okay, so again, x is equal to, in my case, that's going to be e to the 3rd power. So again, press the second natural log for that. E to the, let's see, e to the 3rd minus 3. Okay, so 17, in this case this is 17.0855. Okay. So I'm kind of bleeding into this one. This one I'm not going to do number 6. It's very similar to either this one or that one. Okay, you're just going to have to, well, I will do at least one thing. I kind of have to do it now that I saw something. I'm going to take the natural log of both sides. So when I take the natural log of both sides, I end up with 8x is less than or equal to the natural log of 50. Okay, so again, I took the natural log of both sides. And then now, the only thing that's different about this is that when I divide by -8, all right, this inequality is going to switch. So I have x is greater than or equal to whatever the natural log of 50 divided by -8 is. So natural log of 50 divided by -8. Okay, so in this case that's -0.4890. Okay. Alright, so that's it for that. All I would say to you, just for the sake of time, is make sure you always isolate this e, for example. I'm not going to do this one, but, well, maybe I should. I don't know. I don't want to do all of them, but maybe I have to. Right, on this one I have to isolate that, add the 3. Now on this one I'm going to take the natural log of each side. And that wasn't wrong, I just want to put natural log of, let's see, that was 15. Okay, I added the 3, then I take the natural log of each side. So I take the natural log of this side, I end up with 4x minus 1 is equal to the natural log of 15 on this side. So now it becomes like a linear function. Remember, natural log of 15 is just some number. I don't know what it is. If you want to go ahead and come to your calculator and put natural log of 15, you can. It doesn't matter to me. All right. So, but to solve this is the same. We're going to add 1. So we're going to add 1 to this side, and then we're going to divide. We have 4x is equal to the natural log of 15 plus 1. We're going to divide this by 4. Okay, so this would be the natural log of 15. Let's see. Natural log of 15 plus 1 divided by 4. Okay, so you can actually put all that in there. So we have x is equal to, I'm going to write that over here because I'm basically out of room, 0.9270. Okay. So that's that for that. Let's see, I'm not going to do number 8. Number 8 is essentially like what we have on number 5. Same idea. Well, on number 9, let's do number 9. Alright, so number 9, we're going to start off the same. Please try to isolate. Isolate the base E exponent thing over here. Alright, now we're going to divide this by 2 first. Okay, so on this side, now I can take the natural log of each side, and this is negative 3/2. I don't think I can take the natural log of a negative, but let's see. Okay. Now, on a problem like this, okay, assuming I did everything correctly, and I did, alright, this right here, this I should have noticed, this right here is never going to happen. You're never going to have a negative number here, and you can see that because when I try to put the natural log of negative 3/2, okay, when I try to do that, it gives me an error. So again, you cannot take the natural log of a negative, so therefore this is no solution. Okay, so just remember that. You cannot take the log of any kind of a negative number. Alright, let's go ahead and move on to number, let's see, which one's good. Let's look at 12. Now, on 12, this is kind of difficult because you do have 2 natural logs and you have a number, right? Remember what I kept telling you, isolate either the log or E. Now in this case, because you have 2 natural logs, you're going to have to find a way to combine it. And by the properties of logarithms, so I'm citing stuff here that you should already know. If you add 2 of the same logs, you can actually multiply the insides of that. Okay, so this is the same thing. In this case, this is the natural log of 15x squared. It's greater than 9, so that is the same thing. Okay, so then at this point I have 1 natural log, which is what I wanted. That's great, and I can go ahead and just try to solve for, in this case, x squared. So I'm going to use E now. When I use base E, I end up with 15x squared. On this side, I end up with e to the 9th. This is definitely not going to be a pretty number, okay? But that's okay. We're going to divide by 15. Okay, so we have x squared is greater than e to the 9th over 15. Again, and if you want to, you can go ahead and put that in your calculator to see what it is, but I'm trying to solve for x, so I'm going to take the square root of each side. and then see what happens. It is kind of a quirky little problem there, but let's see, we have the square root of e to the 9th divided by 15. So this one's going to be 23.2423. Now, I know what you're thinking. You might be thinking, well, what about the plus or minus? I thought you said that when you took the square root, you get a plus or minus, and that would be correct. Right? However, on this one right here, if I would take the negative 23, and I were to plug it in back in here, that would not work. All right, and it wouldn't work because remember, you cannot take the log of a negative number. Okay, so let's just check our answer if you wanted to. I'm going to store this last number. Remember, I have this STRT down here. Okay, so if I don't give you the answers and you are trying to figure out if you did this right, maybe you can do this, right? So we're going to store this as X. And then my hope, and God knows I'm really hoping this, because I didn't check this ahead of time, is that when I put this on there, at the very least, it should give me something greater than 9, or pretty close to it. Sometimes the calculator will do certain roundings of numbers, but it looks like in this case that is correct. So anyway, but if I were to do that with a negative number, it wouldn't work. And I mean, I guess I can show you that real fast. Let's say that this is the same number, but instead of that I have a negative. Okay, and now we're going to store this as X. Okay, and now we're going to check out the same number. And it gives me a non-real answer, which means, again, you cannot take the natural log or any log of a negative number. Okay? Alright, well, that's it for that. I hope it wasn't too bad, and we'll just see how it goes.